This video is going to review solving rational equations using the LCM. So yesterday we talked about using cross multiplication to solve. Cross multiplication, remember, can only be used when you have one fraction on each side. As soon as you have more than one, we can't use it anymore. So just to refresh, I have one fraction on the left, one fraction on the right. I'm going to cross multiply, and we always write cross, so 3 times 4x plus 5 equals cross 9 times x plus 1. You're just solving a proportion. It doesn't matter whether you cross with the 3 or cross with the 9 first. If your equation is backwards, it's still the same. From there, you would just carry on to solve that equation. Okay, another thing to remember as we're working through these today is that if your solution is one of the excluded values, we have to throw it out. It's extraneous. So like for number 1, if my solution is x equals -1, I can't use that. So I would say no solution because it would make the denominator 0, which is always going to be bad. Okay, but what we're talking about today is what if it's not one fraction on each side? Then we're going to use the LCM. Now here's what's really, really important. The goal when we are using the LCM is to eliminate the denominators, not make a common denominator. So since we have an equation, we don't have to multiply. We're not restricted to just multiplying by 1. When I have something where I'm just trying to add, let's say 1 over 3x plus 4 over 2x squared, maybe, I don't know. I'm only allowed to multiply by 1 because this is an expression and I'm not allowed to change its value. So the way that we made a common denominator would be to multiply this one top and bottom and multiply this one top and bottom. That's how we get 6x squared for both denominators. Then we can combine. This is really just times 1. This is really just times 1. But if I have an equation, I don't have that restriction anymore. If I make this equal to 10, well, I don't need to multiply by 1. As long as I do the same thing to both sides, I can do whatever I want. So what we're going to do instead on these problems is to multiply everything by the LCM just on the top. And what that should do, if we've picked the correct LCM, is all the denominators should cancel out. And then we have something without fractions left that we can solve. So let's just look at 2 examples. We already looked at a couple of these in class. This is just kind of a refresher video. So let's start with number 4, okay? I have 3x over x plus 1 minus 5 over 2x equals 3 over 2x. So remember that this x plus 1 is its own factor. So the LCM here is going to be, take a second and see if you can guess what it's going to be before I write it down. It's going to be 2x, x plus 1. I'm going to need one of each of those things, okay? Remember, the x that's a factor on its own is not the same as the x that's part of the x plus 1 factor. Those count as 2 different factors. So that's our LCM. So what we're going to do, and I'm going to rewrite this with a plus and negative. I'm going to give myself a little space. So I have 3x over x plus 1 plus -5 over 2x equals 3 over 2x. We've done this before where we just need a little bit of room. I'm going to multiply every single fraction on both sides by 2x, x plus 1, because that's the LCM. 2x, x plus 1. Okay? And because I've only multiplied on the top, if anything on the top cancels out with a factor on the bottom, remember this is all one factor, then we can go ahead and do that. And that's exactly what happens here. X plus 1 divides out, and all I have left is 3x times 2x. No more fraction. Then I have the 2's cancel out and the x's cancel out, so I'm left with -5 times x plus 1. Again, no more fraction. That's the goal. And then on this side, 2's and x's, and I have 3 times x plus 1. So from here, we're just going to distribute, combine like terms, solve just like normal. So I get 6x squared minus 5x minus 5 equals 3x plus 3. Since I see a quadratic, I'm going to start by getting this equal to 0. So 6x squared minus 8x minus 8 equals 0. We're going to hope that this is factorable. We shall see. I don't know if it will be, but we will find out. So I see a GCF of 2 to start. So I get 3x squared minus 4x minus 4. And this is not a equal to 1, so we're going to have to group it. So I get negative 12 and negative 4. So the magic numbers that we're trying to find on the side, and this does work, negative 6 and 2. So it is factorable. So I have my GCF of 2, but I don't need that right now. I need to do the grouping step. So I have 3x squared minus 6x plus 2x minus 4. That's all still equal to 0. Split it in half. I have 2 times 3x times x minus 2 plus 2 times x minus 2 equals 0. I'm running out of room, so I'm going to come up here. So now we can see our factors are going to be 2 times x minus 2 times 3x plus 2 equals 0. Setting each of those factors equal to 0, we get x equals 2, and we get x equals negative 2/3. Now, before I box those in, I need to come up here and check my denominators. My excluded values are negative 1, I don't have that, and 0, which I also don't have, so that means both of these solutions are good. Okay? So the quadratic stuff is not new. What's new is that multiplying by the LCM to cancel out the denominators. Let's look at one more example if you'd like to see another one. We'll skip down to number 6. Now this one, if I remember correctly, I think is an example where we do end up with an extraneous solution. So that'll be good to see. So what we need to do here is to find the LCM, I need to factor all the denominators. So I'm going to do a little rewriting. I have 6 over x minus 3. That's all one factor, so I'm adding parentheses. Leave some space. Equals 8x squared over, this is a difference of squares, x plus 3, x minus 3. I'm going to change that minus to a plus negative 4x over x plus 3. So hopefully you can see that the LCM is going to be x plus 3, x minus 3. I need one of each of those in order for everything to cancel out. So I'm going to come here and multiply every single term on both sides by x plus 3, x minus 3. And we'll see what cancels out. So the first one, x minus 3. So I have 6 times x plus 3 is what's left, equals. Both of these divide out, so I get 8x squared is all that's left. And then the x plus 3, so I get minus 4x times x minus 3. And so now we have no more fractions. We do have a quadratic, so that kind of stinks. But go ahead and pause your video and see if you can solve this the rest of the way. And then look at your solutions and make sure that you don't have anything that's extraneous. I'll come back with the work here in 3 seconds. Okay, so this is what you should get once you factor and get everything ready to solve. Now notice, this is not an a equal to 1, so you do have to use factoring by grouping or some other method to get that. It's not a shortcut, so you got to get those right factors. When I set these equal to 0, I get x equals positive 3 over 2, and I get negative 3. Now let's go back to the original, and we can look at the factored denominators all right here. Excluded values are going to be positive 3 and negative 3, which means we cannot keep this one. This solution is extraneous, and the only correct solution is 3/2. Okay, so that's how we can use the LCM. Cross multiplying is really simple if you can do it. Again, if you have more than one fraction on one side of the equation, we can't cross multiply because it's not a proportion, so we have to use this LCM method. So that's what you need to know. I'll see you later.